1918, a group of experienced lobster fishermen working the deep water off Australia's eastern coast came back to shore one afternoon and refused to go out again. These were not casual sport fishermen. They were the outside crayfish men of Port Stephens, working the outer reefs at the edge of the continental shelf, miles beyond protected harbor waters. Greek-Australian by background, hardened by years on open ocean swells, they were not men who scared easily, which is precisely why what happened matters. The gear disappeared before anyone saw anything. The story did not start with a sighting. It started with missing equipment. In the late southern autumn of 1918, the Greek-Australian lobster fishermen working the deep outer grounds off Broughton Island, New South Wales, began arriving at their marker buoys to find nothing beneath them. Not damaged pots, not raided pots, nothing. The pots were gone. The mooring lines were gone. The anchor weights were gone. The catches of living rock lobster inside them were gone. This was a working fleet. These men ran a commercial operation on one of the most productive stretches of lobster ground on the entire New South Wales coast. The eastern rock lobster, Jassus verotzi, was their income, and the outer Broughton Island grounds were where the largest and most valuable specimens concentrated, in water between 115 and 150 meters deep, at the precise boundary where the inner continental shelf begins its drop toward the abyssal plain. The pots they were losing were serious pieces of commercial equipment. Each one was approximately 3 feet 6 inches in diameter, built from hardwood timber and heavy-gauge galvanized wire. Each was anchored to the rocky substrate by weighted mooring lines designed to hold position against current and swell at depth. A fully loaded pot on a productive set would contain between 2 and 3 dozen mature specimens, each weighing between 1.5 and 3 kilograms. The total weight of pot, line, hardware, and live catch combined was enough that recovery required a hand-cranked winch mounted to the gunnel. These were not objects that washed away. Marine biologists and fisheries managers have studied shark interactions with fixed commercial traps extensively. A 2010 FAO technical paper, Fisheries and Aquaculture Technical Paper, number 563, documents in specific detail what those interactions produce. Sharks bite through lines. They crush mesh panels to access prey inside. They leave torn wire, broken timber, severed cordage, and biological material. They leave evidence. What the Broughton Island fishermen were finding was the complete absence of evidence. No wreckage, no line ends, no displaced sinkers on the bottom. The gear was simply not there. The scientist who spent his career saying no and then didn't. David George Stead was not the kind of man who believed fishermen's stories. His public record said so explicitly. In 1907, 11 years before the Port Stephens encounter, a sea monster sighting briefly gripped Sydney Harbor. Witnesses described a large, unidentified animal moving through the inner harbor waters. The story ran in the Sydney press. Public interest was immediate. Stead investigated, interviewed the witnesses, examined the reported location, and concluded the sighting was a misidentification of a known species exaggerated in the retelling. He said so publicly, under his own name, in terms that left no ambiguity. That debunking established him in the scientific record of the period as a naturalist whose default position on extraordinary marine claims was systematic disbelief. His credentials made that position credible. Born in Sydney in 1877, Stead built one of the most substantial careers in Australian natural history of his generation. He served as manager of the New South Wales state trawling industry. He founded the Wildlife Preservation Society of Australia in 1909, the oldest conservation organization in Australian history. He published extensively across ichthyology and fisheries science for more than 5 decades. He was not a romantic. He was an administrator, a taxonomist, and a fisheries manager who dealt in measurable things. When the Port Stephens report reached him in 1918, he went out personally. He interviewed each fisherman individually, not as a group, where stories converge and social pressure shapes testimony, but one at a time, in the manner of someone looking for inconsistencies. He spoke separately with Inspector Peyton. He examined the equipment records and the disrupted mooring logs. He found no inconsistencies. What he found instead was a set of independent accounts that agreed on the same central details: the coloration, the scale, the behavior, without the kind of elaboration or embellishment that characterizes fabricated testimony. Experienced witnesses describing something real tend toward understatement. They say it was big and stop because they know how it sounds. That is precisely what the Port Stevens fisherman did. Stead recorded everything in his contemporaneous field notes. He kept those notes for the remaining 39 years of his career. He never publicly dismissed the account. He never privately walked it back in correspondence. When he was assembling what would become his final major publication, Sharks and Rays of Australian Seas, released posthumously by Angus and Robertson Sidney in 1963, 6 years after his death, he placed the Port Stevens encounter directly in the main text under his own name, without qualification. The closing sentence of his treatment has been cited continuously for more than 60 years. The local fisheries inspector of the time, Mr. Peyton, agreed with me that it must have been something really gigantic to put these experienced men into such a state of fear and panic. Read that sentence carefully. He did not write the men believed it was gigantic. He did not write it appeared to be gigantic. He wrote it must have been a first-person scientific conclusion, written for posthumous publication, by a man who had built his public reputation on reaching the opposite conclusion about accounts exactly like this one. The other times Australian waters produced the same answer: unknown. The Port Stevens encounter was not the only time the deep water off eastern Australia refused to give a clean explanation. It was just the most documented one. What makes the broader pattern significant is not the individual sightings. It is the consistency of a specific detail across accounts separated by decades, different locations, and witnesses who had no contact with each other. And in several cases, no knowledge that anyone else had reported anything similar. In 1956, 38 years after the Port Stevens encounter, a commercial trawler operating out of Eden, New South Wales, approximately 480 kilometers south of Broughton Island, reported an encounter with a large pale-colored marine animal at the edge of the continental slope. The crew described the animal as moving alongside the vessel at a depth that kept its full body below the surface, visible only as a shape through the water column. The skipper, a man named Robert Tully with more than 20 years of commercial fishing experience in those waters, estimated the visible portion of the animal at between 25 and 30 meters in length. He filed a report with the NSW Department of Agriculture Fisheries Division. The department logged it. No follow-up investigation was conducted. That report remained in the departmental archive, uncited and largely unexamined, until researcher David Hatcher Childress referenced the archive file in his 1992 survey of Australian maritime anomaly records. The pale coloration appeared again. In August 1964, the crew of a commercial prawn trawler working the Clarence River offshore grounds, approximately 600 kilometers north of Broughton Island, reported a large white animal moving through the water approximately 40 meters off the port beam. The first mate, whose name appears in the original harbor master's log at Yamba as G. Buchanan, described the animal as moving without visible surface disturbance. No wake, no fin break, no dorsal profile, suggesting a body moving well below the surface at considerable depth while still being visible. Buchanan's estimate of length, recorded in the harbor master's log on 14 August 1964, was at least the length of two of our boats placed end to end. The vessel in question was a 15-meter prawn trawler. That placed his estimate at a minimum of 30 meters. Again, pale. Again, the continental slope. Again, experienced commercial operators with no financial or social incentive to fabricate. The pattern across these accounts, separated by geography and decades, produces three consistent data points that no single conservative explanation accounts for simultaneously. First, the coloration. Great white sharks, Carcharodon carcharias, display countershading, dark dorsally, white ventrally, with a sharp transition line. What the Port Stevens fishermen described in 1918, what Tully's crew described in 1956, And what Buchanan recorded in 1964 was uniform paleness, an animal that appeared white or near white across its visible surface. Leucistic individuals of known shark species have been documented. A confirmed leucistic great white juvenile was recorded off Kangaroo Island, South Australia in 2015 and reported in the Journal of Fish Biology. But leucism in large marine predators is documented at a rate of less than 0.1% of observed individuals. 3 separate encounters across 3 separate decades, each independently describing the same anomalous coloration, is not a rate consistent with rare individual variation. Second, the location. Every encounter occurred at or immediately adjacent to the eastern Australian continental slope, in the precise zone where shelf water transitions to deep pelagic water. This is not a coincidence of geography. Continental slope boundaries are ecologically distinct environments. They concentrate prey species at depth transitions. They channel cold, deep-water upwellings, and they represent the interface between the well-surveyed coastal fauna and the almost entirely unsurveyed deep-water fauna of the abyssal plain. Third, the behavior. In each case, the animal was observed moving in a manner inconsistent with the surface-oriented feeding behavior of the large shark species known to inhabit the region. No attack, no surface break, no dorsal fin. Movement through depth at scale without the biological signatures that experienced commercial fishermen. Men who encountered large sharks routinely would have recognized immediately. 3 accounts, 3 decades, 3 locations along the same geological boundary. What modern science actually found when it finally looked. For most of the 20th century, the deep water off the eastern Australian continental slope was not ignored because scientists thought nothing was there. It was ignored because getting there was prohibitively expensive, technically demanding, and institutionally low priority compared to the commercial fisheries of the inner shelf. That changed in 2006. In that year, CSIRO, Australia's national science agency, launched the first systematic biological survey of the eastern Australian deepwater slope as part of the National Environmental Research Programme's Marine and Coastal Hub. The survey used a combination of baited remote underwater video systems, BRUVs, otter trawl sampling, and acoustic profiling to examine the water column and seafloor between 200 and 2,000 meters of depth along sections of the slope directly adjacent to the waters where the 1918 encounter occurred. The published findings, released across several papers between 2007 and 2013, were striking in a specific way. The survey did not find a sea monster. What it found was something that in its own way made the 1918 dismissals harder to sustain. At depths between 400 and 800 meters, the upper mesopelagic zone directly below the lobster grounds the Port Stephens fishermen had worked, the survey recorded biological diversity levels significantly higher than existing predictive models had estimated. More specifically, the trawl samples returned multiple specimens that could not be matched, at the time of collection, to any described species in the global taxonomic database. These were not microbes. Several were cartilaginous fish, the taxonomic class that includes sharks and rays, of sufficient size to be significant. One specimen, a deepwater shark recovered from 620 meters on the slope section nearest to Broughton Island, required 14 months of taxonomic analysis before it could be tentatively assigned to a known genus. Tentatively. A 2010 census of marine life, the most comprehensive global marine biodiversity audit ever conducted, involving 2,700 scientists from 80 nations across a 10-year research program, concluded that approximately 91% of marine species remain formally undescribed. The figure requires context that is almost never provided when it is quoted. The overwhelming majority of those undescribed species are microbial, but the census also concluded, in its final report published in PLOS I in October 2010, that the deep-water slope environments of the southwestern Pacific, including the eastern Australian margin, represented one of the 5 highest priority unsampled biological zones on the planet for large marine fauna. Not microbes, large fauna. The census identified the eastern Australian slope specifically because of a combination of factors that made it biologically anomalous. the strength and variability of the East Australian current, which transports warm tropical water southward along the slope and creates layered thermal environments that support diverse and unexpected species assemblages at depth, the extreme steepness of the slope gradient, which concentrates nutrients at the shelf edge, and the almost complete absence of systematic biological sampling prior to 2006. In practical terms, what this means is the following. The water column directly above the site of the 1918 encounter, the specific geography where experienced commercial fishermen, a government inspector, and a credentialed skeptical naturalist all concluded something very large and unidentified had been present, was not subject to any systematic biological survey for 88 years after the encounter took place. When that survey finally happened, it found species that had not previously been described. It found them at the exact depths where a large pelagic animal moving below the surface would spend the majority of its time, between 400 and 800 meters, in the mesopelagic zone that sits directly beneath the lobster grounds, connected to the surface by the same slope boundary the 1918 animal was reportedly moving along. The survey did not resolve the 1918 encounter. It was not designed to. It was a biodiversity audit, not a cryptozoological investigation. But its findings produced a specific scientific conclusion that the popular dismissal of the Port Stephens account has never adequately engaged with. In 2012, CSIRO marine biologist Dr. John Pogonowski, one of the lead taxonomists on the slope survey, stated in an interview with the Australian Geographic that the eastern Australian slope had yielded, in his words, more taxonomic surprises than almost any comparable survey zone in the southern hemisphere. More taxonomic surprises, from the water directly below where the fishermen's pots were disappearing in 1918. That is not confirmation of what the Port Stephens fishermen saw. The survey data does not support the survival of any extinct macropredator. The extinction record for Ototus megalodon, placed definitively at 3.6 million years before present by Pimiento and Clements in their 2014 PLO-S1 analysis, was not disturbed by anything the CSIRO slope survey recovered. What the survey data does support is something more uncomfortable for the dismissive position. It supports the conclusion that the eastern Australian continental slope, the precise geography of the 1918 encounter, was, at the time of the encounter and for the 88 years that followed it, a biologically active deep water environment producing species unknown to science, operating at depths and in a water column that experienced surface observers could detect only partially and imperfectly in a zone where the boundary between the known and the unknown ran almost directly beneath the fishermen's boats. The sounds no one could identify, and where they came from. In November 1997, operators at the National Oceanic and Atmospheric Administration's Autonomous Hydrophone Array, a network of underwater microphones originally installed during the Cold War to track Soviet submarines, detected an ultra-low frequency sound rising from the deep water of the South Pacific Ocean. The sound was extraordinarily powerful. Its amplitude was sufficient to be detected simultaneously by hydrophone stations separated by thousands of kilometers of open ocean. Its frequency profile, the specific pattern of its rise, peak, and decay, did not match any geological source in the NOAA database. It did not match volcanic activity. It did not match seismic events. It did not match any known cetacean species in the global bioacoustics catalog. NOAA analysts named it the bloop. The recording was released publicly. Within months, it had become one of the most discussed, unexplained sounds in the history of ocean acoustics. The reason was specific and documented. When NOAA researchers mapped the geographic origin point of the sound, working backward through the hydrophone network using triangulation, the point of origin placed the source in the deep water of the South Pacific, in a zone that sits within the broader oceanic region of the eastern Australian abyssal plain, not directly above the Broughton Island grounds, but in the same connected deep water system, the southern Pacific Basin, that the eastern Australian continental slope drains into at its base. For 14 years, the bloop remained officially unexplained. In 2012, NOAA released a formal analysis concluding that the most probable source was icequake activity, the fracturing of large Antarctic ice formations producing infrasound that propagated northward through the deep sound channel. The analysis was published and broadly accepted within the oceanographic community. The icequake explanation fits the frequency profile and the propagation pattern. But the icequake resolution of the bloop is not the most relevant part of the story for the eastern Australian waters. The relevant part is what the bloop investigation revealed about the detection capacity of the existing hydrophone network in the southwestern Pacific. When NOAA analysts attempted to refine the origin point of the 1997 signal, they discovered a significant gap in hydrophone coverage directly over the eastern Australian continental slope and the adjacent abyssal plain. The geometry of the Cold War-era array, designed to monitor Soviet submarine movements in the North Pacific and North Atlantic, left the southwestern Pacific, including the waters east of Australia, as one of the least acoustically monitored ocean regions on the planet. In plain terms, if a large biological sound source had been producing calls from the eastern Australian slope in 1997, or in any year prior, the existing hydrophone network would have had a significantly reduced probability of detecting it compared to equivalent sources in the North Atlantic or North Pacific. The gap was not theoretical. It was mapped. A 2004 paper by Stafford, Newkirk, and Fox, published in the Journal of the Acoustical Society of America, one of the most cited papers in deep ocean bioacoustics, documented the detection limitations of the NOAA array in the southwestern Pacific specifically, and noted that biological sources of sufficient amplitude to register in better monitored zones might fall below detection threshold in the eastern Australian region due to array geometry. This matters in a specific and verifiable way. In 2014, a separate passive acoustic monitoring study, Risch et al., published in Biology Letters, deployed dedicated hydrophones in the Southern Ocean south of Australia and detected a large biological sound source producing calls in a frequency range that did not match any species in the existing cetacean bioacoustics database at the time of detection. The source was eventually attributed, after 2 years of analysis, to Antarctic blue whales, Balanoptera musculus intermedia, using a previously undescribed call variant, a call type that had been produced by a known species for an unknown period of time without being detected, simply because no one had placed a hydrophone in the right location. A known species, producing sounds for an unknown duration, undetected because the monitoring infrastructure was not present. Apply that finding to the eastern Australian continental slope. No dedicated passive acoustic monitoring array has ever been permanently deployed on the slope section adjacent to Broughton Island. The NOAA Global Array has reduced sensitivity in that specific zone. The IMOS, Australia's Integrated Marine Observing System, operates acoustic receivers in Australian waters primarily for tracking tagged individual fish and marine mammals in the inner shelf zone, not for broadband passive monitoring of the deep slope environment. What this means is direct. If a large, unidentified biological sound source, an animal of the kind that would produce the low-frequency calls characteristic of very large marine vertebrates, were present in the water column of the eastern Australian slope, the existing monitoring infrastructure would have a structurally reduced probability of detecting it. Not zero, reduced. The distinction matters because the absence of a detected acoustic signature is routinely cited as one of the reasons to dismiss the possibility of a large unknown animal in Australian deep water. The argument runs, if something that large were present, we would hear it. The bioacoustics record says otherwise. We heard Antarctic blue whales only when we put a hydrophone where they were. We resolved the bloop only when we examined the coverage gaps in the existing network. The eastern Australian slope remains, in the language of the 2023 GEBCO Seabed 2030 Progress Report, one of the least continuously instrumented marine environments in the southwestern Pacific. The fishermen in 1918 had no hydrophones. Neither in any meaningful operational sense does the slope below Broughton Island today. The deep water is not silent because nothing is producing sound. It may be silent in the record, because no one has been listening in the right place. If you want more documented ocean mysteries grounded in real evidence, subscribe, like the video, and share your thoughts below.